Alright, problem number 5. It is now between 10 and 11 o'clock. 6 minutes from now, the minute hand of an analog clock will be exactly opposite the place where the hour hand was 3 minutes ago. What is the exact time now? Alright, this is a real doozy. This is a tough problem. But, part of the problem is just even understanding what they're asking and understanding whether, we have 6 minutes from now, the minute hand will be exactly opposite the hour hand, where the hour hand was 3 minutes ago. Oof. It's hard to even visualize what's going on. So let's start by drawing a clock, alright? Let's look at the picture, and hopefully that'll help us figure this out. So we have 12 up here, 6 down here, we have 3 over here, and we have 9, 10, 11, we have 1, 2, 4, 5, 7, and 8. Okay, so that kind of looks like a clock. And then we have the center here where the hands are attached. And we know that the hour is between 10 and 11. So we know that the hour hand, which is usually the shortest hand, right? So it's either pointing somewhere between the 10 and the 11. So I'm going to actually sort of dot those in, because our range that the hour hand, where the hour hand's pointing is fairly small, right? It's just somewhere between the 10 and 11. And if the minute hand is exactly opposite of that, then but you have to be careful because it's the minute hand. Let's see, in 6 minutes from now, it would be exactly opposite the place where it was 3 minutes ago. So, but when it is opposite, even though that is 6 minutes from now, it's somewhere in here, right? So that helps us narrow the range down. Okay, I'm making the minute hand longer here. So we know that 6 minutes from now, it's going to be somewhere between the 4 and the 5, because that's going to be opposite of where the hour hand is. Okay, so 6 minutes from there has to be somewhere back here. So at the minimum, it's like here, right? Because this is 5 minutes, so 6 minutes would be about here. All right, and 6 minutes from here is about here. Okay, so we know that right now oops, I was trying to erase that little, oh, I got rid of my edit undo. Alright, I'm just gonna forget that. Alright, so we know that 6 minutes, 6 minutes from now, the minute hand is going to be in this range. So right now it's got to be 6 minutes back from that. So we know that it's somewhere in, actually let me draw something. Okay, so we know it's got to be somewhere between here and here. That's where we're at now, somewhere in there. So we got to narrow down, right? So because that's what we're looking for, right? We actually want to know what time it is right now. And the hour part is easy. The hour part it's 10 o'clock, somewhere in there, because it's somewhere between 10 and 11. So we know the hour of the current time is 10. But what we don't know is the minute, right? We don't know the minute part. And that's what we've got to figure out. But we've got to narrow down. It's somewhere between, looks like about 10:14 and let's see, this would be 10:19. Okay, so if we get a number that's in that range, then we know we're doing good. We know we've probably figured out something. So let's go ahead and work through this problem. Now, wouldn't it be nice if we had some way that if we could just plug in any minute, we could figure out the position of the hands? Okay, so we would like to have some sort of a function that if we put in the minute, we could get the position of either the hour hand or the minute hand. Okay. So the minute hand's pretty easy, right? Because it goes around once per hour, right? It goes a full 360 degrees every hour. So, you know, one way I could look at this, now we have actually the hours marked on this clock, but we know that every time it moves from the 12 to the 1, that's 5 minutes, and another 5 minutes, and another 5 minutes, another 5 minutes, okay? So, we could either work this out in degrees, or we could work it out in minutes. So, I've actually done it both ways, but since we're all familiar with degrees, why don't we just do that, okay? So, up here, we'll call this 0 degrees, and so we have 360 degrees in the clock, right? And we have 12 hours. That's divided up in 2. So that means we have 30 degrees per hour. So this is, you know what? I'm going to write it. I'm going to write it in red. So this is 30 degrees. This is 60 degrees. This is 90 degrees. And here we have 120 degrees at the 4. Here we have 150. And here we have 180. And we have 210 degrees, 240 degrees, 270 degrees, 280 degrees, 290. Whoops, what am I doing? Hold on, I've gone crazy. Oh, darn it. And undo. Alright, let me see if I can erase just what I want. Alright. Because this isn't 280, is it? This is, what? It's 300. So I'm trying to erase that without erasing the, alright, there we go. 300 degrees. Alright, and then we have 330, and we have 360 up here at the top. Alright, so that's also 0. So once we've gone 360, we've gone all the way around. Alright, well, so we know that every 5 minutes the minute hand travels 30 degrees. So we have, let me go back to black here. Oops, here we go. Alright, so the minute hand, okay, we've got 30 degrees in 5 minutes, so that's 30 degrees per 5 minutes, or we can write that as 6 degrees per minute. Alright, so if we write that the position of the minute hand, let me just, how should I write that? Let's see. So the position of the minute hand, I'm going to write it as M, is equal to 6t, right? If t is the time. Now let's just define those variables here. Let's say, where should I need some space. Let's say that t is the current time. Current time, all right? And let's say that m is the position of the minute hand, and that's in degrees, right? So I'm going to need some more room here. All right. So then if we plug in whatever the current minute is, actually, because we're kind of ignoring the hour for now because we know it's 10. So if we plug in any given minute, like if we plug in 20 minutes, then we're at 6 times 20, which is 120 degrees, right? So for any given minute, if we just use this formula here, we can get the position of the minute hand. All right. So let's try and do the same thing for the hour hand. Okay. So let's define a function h to be the position of the hour hand. So I'm just going to write that here where I have my variables defined. So this is the position of hour hand, and again in degrees. Okay, so we know we're starting out at 300 degrees, right? And then we're adding, we're somewhere in here. And then so for every minute we move a little bit closer to the 11. Okay, so how much closer? Well, we know that in an hour it's going to move 30 degrees. So in this case we have 30, and I should write this as the hour hand, just to keep this all straight, because this is a problem that requires a lot of straight thinking. So let's write this as the hour hand moves what? It moves 30 degrees in an hour, right? So that's 60 minutes. Alright, so here we had the minute hand moved 30 degrees in 5 minutes, and the hour hand moves 30 degrees in 60 minutes. So that moves a half of a degree per minute. Alright? So we're starting at 300, and then for every minute that goes by we're moving half a degree. So if we write 1/2 t, alright, so half a degree per minute, then we'll get the position of the hour hand at any given minute that we're interested in. Alright? So that's the other formula we're going to work with. So let's test that out. If we're at, say, 10:30, so the minute is 30 minutes, so we plug in that, we should be at 315 degrees, which is exactly halfway between the 10 and the 11. So that makes sense. Alright, so now we have two functions, one for the position of the hour hand and one for the position of the minute hand. Alright, so let's go back up to our problem statement. The problem statement says that 6 minutes from now, so that's t plus 6, right? So I'm going to write h for t plus 6, I'm going to make it a subscript for now, is equal to the position of the minute hand, the minute hand of the clock, let's see, 6 minutes from now, actually, you know what, I wrote that wrong, didn't I? So, let's see, so let's read carefully. 6 minutes from now, the minute hand of an analog clock will be exactly opposite the place the hour hand was 3 minutes ago. Okay, so the minute hand in t plus 6 minutes is equal to the position of the hour hand 3 minutes ago, so that's t minus 3, and this is exactly opposite, so it's 180 degrees back, right? So it's got to be exactly opposite, so that's 180 degrees back from the hour hand. Okay? So let's figure out what that is. We have a couple of functions here. So let's see. The minute is 6t, but we want to know not at the current time. We want to know what it was, what the position of the minute hand was 6 minutes ago. Right? So that's 6 minutes from now. 6 times t plus 6 is equal to the hour hand. So we have 300 plus, and it's the hour, where the hour hand was 3 minutes ago. So here we have to use t minus 3 in order to get where the position of the hour hand was 3 minutes ago, and then again it's exactly opposite, so it's 180 degrees less than that. Alright? That all makes sense? So here we have the position of the minute hand 6 minutes from now will be exactly opposite, that's this 180 degrees, the position of the hour hand 3 minutes ago.